Welcome back. So HITEM3D outputs some really good meshes, and this will be the case study. I want to analyze the non-manifolds, if there are any holes, if there are any high creases on the models. So as you know, within HITEM3D, the models will have around 2 million faces. And let's take a look. This is the initial one, and afterwards I hit retry. Within history, you're going to maintain all of those. So you can do this up to 3 times for free for each model. It can enter the reprocess. As you can see over here, the second model is a little bit better over here for the rooster head. This will be the third one. Again, the same resolution. It will have the following detail added. And this will be the last one. So each model can be processed up to 4 times in this case. Now, I already prepared the FBX of those over here. So this is the reference, the input image. We see the dimensions. So I'm going to import all of those within GeoMagick Rep, and I want to compare those. I'm also curious regarding the size, if there are any changes between those iterations, or if they will be perfectly overlapped. So we have the model now being loaded, rooster 1, 2, 3, and 4. And we have the models over here. This looks to be the first one, so they are still being imported. We see over there that one of the texture for the ground floor will be with white, and that's the initial one. And what I really like about HITEM3D is that they will all use the same reference. So even though the model has been reprocessed, they will share the same origin and also the same size. So if I will hide the other roosters, so iteration 2, 3, and 4, this will be the original one. The original one also had the texture for the ground floor with white. Now let's do a mesh doctor and see if the mesh will require any high amount of processing. So most likely it will, because just like within 3D scanning, all models will require to be a little bit fixed. But what I like is that we don't have any manifolds, we don't have any self-intersections, and we also don't have any small holes. So there are some areas that will be, let's say, small tunnels, such as the one over here. Also high crease, but those can easily be processed over here. So let me just reposition this in the viewport. And I will hit apply in order to have this process. So again, this is the first iteration, and in my opinion, it's quite good. It doesn't have any manifolds, no self-intersections, and also no holes. Now, the processing will depending on the computer specification, especially over here that there are so many spikes. So we see over here 127,000 spikes, also highly creased edges. It's important that we're gonna fix those, especially if you want to take this further within CAD. If you just want it as a simple 3D print, that's not a problem. You can just output it, load it in, and have that 3D print created. But usually it's a good idea to fix this if you want to further process the model within a CAD solution. So maybe within this video, I'm not going to go ahead and process all the models, but I'm really curious if there are any manifolds, self-intersections, or holes within the models. If you also follow my previous video, you know that I also presented how to edit the meshes, both within GeoMagick, but also using free solutions such as Blender. The workflow will be quite similar. We're going to do a selection and a loop selection, delete those faces, and afterwards we can fill that. GeoMagick does it a little bit faster and more automated, while within Blender, we really need to do that filling manually, and afterwards we need to do a little bit of sculpting in order to have those processed. Now, I see that the processing takes quite a lot over here, especially for the high amount of spikes, those 127,000 spikes. But we see over there on the bottom the progression bar. So this is estimated. It has been stuck for 2 minutes for quite a long time now, but knowing GeoMagick, it will soon manage to process this, and we can see the final result. Again, it's really good that there are no manifold edges, self-intersection, and holes. So this is a big plus, especially for this model for HITEM3D. I also tried other tools. If you follow my research on my channel, you will see that some of those will create those manifolds and self-intersections. And even some recent models, they will also add some small holes within the model. So those will require additional post-processing. Now I also select over here some of the elements on the top of the rooster head. This was not done by Mesh Doctor. This was when I was rotating around the model. But let's see, the model is still being processed. It takes a little bit more time, especially since I loaded 4 of these over here. But while this is still being processed, I'm going to jump over here. And what is really good about HITEM3D is that we have access to voxel resolution at the following resolution. So this is quite high. You will need a paid subscription for this. So you have the free one, which you can use the free trial for this resolution, but you will require the pro one in order to not have that free trial for this extended resolution. As you can see over here, the difference between these two, they will have the same, almost the same amount of credit. So the first month will have more, so you can create a little bit more. But afterwards, that will be only the main difference, as you can see over here. So there are no changes. The only changes is that this will give you access to the high resolution. I'm going to do some testing because not only high resolution is important, it's also important to have good topology on the mesh. And there are other models that will output those with pure geometry. And in my opinion, that's a good approach because in some cases, less is more. For example, I use this wooden rooster over here because it has a lot of intricate details on the surface, and it's mandatory that you're going to have a high resolution in order to maintain those within the mesh. We see the processing time over there on GeoMagick on the bottom, so 4 minutes 20 seconds is still taking a little bit of time to process, but it should finish. Meantime, I'm gonna jump again over here, so let's check also those iterations. So we see the first one, it had that additional geometry on the head of the rooster that wasn't present over here, so we see how that should have looked. So this was the first iteration, this was the second one. As you can see, it will be a little bit better, but if you're gonna check those elements at the top, we should have something like this. So it has added an additional mesh over there. Over here, this is a little bit better. So we see those elements on the top. The total number is 7. So we have 3 over here and 4 over here. And within this model, we're not going to have those, the total amount. So we only have over here 6, as you can see. And within the final model, let's take a look over here. Again, we're going to have 6 of those. So this is the only one that managed to recreate all of those. So all the 7 elements. Now this is still okay, so this managed to be fixed. We still have, after the initial mesh doctor, some self-intersection and high decrease, so I can go ahead and apply those. One of the drawbacks of using this mesh doctor is that the texture will require afterwards a little bit of post work, so you can easily do that within Blender. But again, it's really important what is the final output. If you just want to take this to manufacturing, texture will not be important, but having a good topology on the mesh, it's mandatory so that you can do that CNC machining program. But if you want to take this maybe within a VR, AR, mixed reality application, it's important that you're going to have good texture. So maybe it's not that important that the meshes have self-intersection or manifolds edge, because you're most likely going to use some simplified collision elements within those VR environments. Now, let's take a look at the second one. So this will be the second rooster. I'm just going to do a mesh doctor analysis. I'm not going to have it processed because we saw that it takes a little bit of time. So this is the second iteration. In my opinion, this will be the best one because it will have all the elements on the top of the rooster. And again, this will not have any manifold edges, self-intersection, or small holes. So a big plus. I'm just curious if all those models will maintain that, but I'm pretty sure that they will. So this is a real step forward within the mesh topology. Again, we're going to have those highly creased and spikes, and that's normal since we have so many geometry. And this model, as you can see, it will have those elements. So similar to the roof of a wooden building, they will be present on the surface. Now, if I will go over here and I will disable the custom texture, we're going to see that the mesh will look like this. So in my opinion, this is a really great mesh. If I will also disable the texture for this one, for the first one, we're going to see how this will be the mesh. We can go ahead and we can further remove the spikes. We can do it also manually with the sandpaper, or we can just apply it over here, the general smoothness. So for example, if I'm going to go with high, we're going to see that some of those areas will be smoothed out. What I like about GeoMagick is that it will process everything. So within Blender, we need to go ahead and do that manually. We can also do some smoothing over here with Relax, or we can go ahead and have it remeshed. But again, this is really important if you will take this towards manufacturing. Okay, so this was an overview regarding the mesh quality of highly intricate details of models created with HITEM3D. I'm really curious what's your opinion regarding this, because in my opinion, this is a great generative AI tool that will output high quality 3D models. So I hope you enjoy this kind of content. I'm going to position a similar video over here on the left side, and I will also add a subscribe button to the right. So that's it. Thanks for watching.